Example number 2. X is equal to a cosine t and y equals a sine t, where a is a constant greater than 0. Alright, you may recognize this parametrization, and you might know the curve that it represents. If you don't, well, you'd have to do some good old-fashioned plugging and chugging to figure it out. So let's plug in t equals 0, and if I plug t equals 0, then x is going to be a times the cosine of 0, which comes out to be simply a, and y is going to be a times the sine of 0, which is 0. So that's going to give me the ordered pair a, comma, 0. Just extend this. Let's pick another t. Let's say pi over 2. So then my x is going to equal 0, and my y is going to equal a. So that brings me up here, 0 on the x, a on the y. Next, I'm going to say t equals pi. So I'm progressing from 0 t and getting larger. This time x is going to equal negative a, and y will be back to 0. So that's going to go here. Why not? We'll do one more. For t equals 3 pi over 2, well, the x is going to be 0, and the y is going to be negative a. That's down here. Now, this is going to be really tough to draw, but I hope that you see this makes a circle. Like this. Comes around. Oh, that's better than I thought I'd do. And you might also notice that this was being scribed with orientation counterclockwise. That would be how we would describe the orientation. Now let's answer the question. The point travels counterclockwise around the circle with the origin as center and radius a. It doesn't ask you to do this, but if we want to transform this into traditional Cartesian equation, we can say that x squared plus y squared, well, if I do that, I get a cosine t squared plus a sine t squared, and that will give me a squared cosine squared t plus a squared times the sine squared t. I can factor out the a squared, and that's going to give me cosine squared t plus the sine squared t, which of course you recognize that as 1, so a squared. Put this together, we get x squared plus y squared equals a squared, which is definitely a circle with center of 0, 0, the origin, and radius a, confirming that. But you should know that. You should be able to see that right away and say, I've got a circle with radius a. Part B, we want to find dy dx, which is dy dt over dx dt. Alright, dy dt is going to give us a cosine t. Dx dt is going to give us negative a sine t. So the a's cancel out, and we're left with negative cotangent of t. The slope is always equal to negative cotangent t. Now this is interesting because you can see when t is equal to 0, well, I certainly can't divide by 0. And how is that visually represented? Well, it would be a vertical tangent. See, the slope is undefined here. Then at, let's say, t equals pi over 2, then we're going to have a slope of 0. So that makes sense here. That's when t equals pi over 2. Now for d squared y, dx squared, maybe press pause here, work it through, and then let's check. So this is the derivative of dy dx with respect to t, and then what most people forget is to divide by dx dt. So I need to take the derivative with respect to t of negative cotangent of t. And then I have to divide that by dx dt, and dx dt was negative a sine t. So this is going to be the derivative of negative cotangent t is going to be positive cosecant squared of t, and then that's going to be over negative a sine t. So we can think of this as negative 1 over a sine cubed t, or we can think of it as negative cosecant cubed of t over a. Implications of this, well, we certainly know that as t increases, the concavity is going to change. Some values are going to be positive, some are negative. That makes sense here. In the beginning, we have oops, it chose purple again. In the beginning, we have concave down, and then that's going to change to concave up, concave up, concave up, and then it's going to switch to down and up and down and up and down and up. I find example C to be extremely satisfying. We're trying to find the length of the curve defined parametrically from 0 to 2 pi. Please do that using our formula. Press pause, do it, and then we'll check your work. So this is going to equal the integral from 0 to 2 pi times the square root of negative a sine t squared plus a cosine t squared. So that was dx dt, and this was dy dt. Each of those are squared dt, and we see that we have that property again, that the sine squared plus cosine squared. So this is going to give me the integral from 0 to 2 pi of a dt, which is then going to give me a t from 0 to 2 pi, which is 2 pi a and then minus 0 with the fundamental theorem of calculus. Why is this so satisfying? Why am I so happy? Because this is the circumference. The length of the circle from 0 to 2 pi is the circumference. Circumference equals 2 pi radius. Glorious.